Solving inequalities is like solving equations. The goal is the same, to find values for the variable that make the inequality true. The process is mostly the same. We can add and subtract terms from both sides of the inequality, and we can multiply and divide both sides of the inequality by positive numbers without changing it. But if we multiply or divide both sides by a negative number, remember to flip the inequality to point in the other direction. In this video, we will solve a variety of linear inequalities in one variable, and we'll write the solutions as inequalities and in interval notation. We're going to solve the inequality negative 3w minus 16 is less than or equal to 5w plus 24. The first step is to check if either side can be simplified and simplify it if so. But neither of these two sides can be simplified. Now we're going to collect the variable terms on one side of the inequality. I'm going to add 3w to each side, which gives me the new inequality negative 16 is less than or equal to 8w plus 24. Now we're going to get the numbers together on the opposite side of the inequality. So I'm going to subtract 24 from each side. My new inequality is negative 40 is less than or equal to 8w. Now to solve, all we need to do is divide both sides by 8. I divide by 8 and I get negative 5 is less than or equal to w. Since I divided by a positive number, I do not have to flip the inequality. Well, finally, I'd like to write the solution so that the variable comes first. So I'm going to change the sides of w and negative 5, but keep the pointy end towards the negative 5, because negative 5 less than w is the same as w greater than negative 5. And I'd also like to write an interval that shows the solution. Since I have a greater than or equal to, negative 5 is included in this set, and it goes to infinity. All the numbers bigger than negative 5 are solutions for the inequality. This inequality is 6 times the quantity x minus 2 is greater than 9 minus 2x. First, we check if either side can be simplified. Well, 6 times parentheses x minus 2 can be simplified using the distributive property. If I multiply by 6, 6 times x is 6x, and 6 times negative 2 is negative 12. So 6x minus 12 is greater than 9 minus 2x. Next, we collect the variables on one side. I like to choose a variable with a negative coefficient and add it to each side. So here I'm adding 2x to each side. The new inequality is 8x minus 12 is greater than 9. Next, I collect the numbers. I'd like to get them opposite the term with the variable, so I'm going to add 12 to each side. That gives me 8x is greater than 9 plus 12, which is 21. Now I divide both sides by 8. 8 divided by 8 is 1. So I end up with x is greater, not equal, greater than 21 over 8. Even though it's a fraction, it's a perfectly legitimate answer. 21 over 8 is a number. So I finish up by writing the inequality. X is greater than 21 over 8, Or as an interval, 21 over 8 is the first number and it goes to infinity, all the numbers greater than 21 over 8, and there is no equal. X is strictly greater than 21, so we open with a parenthesis. Uh-oh, fractions! Negative 1/10 y plus 2/5 is greater than or equal to 1/5 y plus 4. The first step is to check and see if we can simplify. In this case, since there are fractions, we can simplify by clearing fractions, multiplying both sides of the inequality by the least common denominator. Here the fractions are tenths and fifths, so the common denominator is 10. I multiply both sides by 10. Now remember that when you're multiplying a fraction by a whole number, you give that whole number a denominator of 1. So 10 times negative 1/10 is just negative 1. And the result of the first multiplication is negative 1y. It's not a fraction anymore. 10 over 1 times 2 over 5 lets us cancel the 5 with the 10 and leaves a 2. So 2 times 2 is 4. Again, the fractions are gone. Negative 1y plus 4 is greater than or equal to 10 times 1/5. That's 10 over 1. So 1 times 10, 5 times 1. The 10 and the 5 cancel and leave a 2 behind. That says 2y. And finally, 10 times 4 is 40. Next we get the variables together. This time I'm going to subtract 2y so that I'll have all the y's on the left-hand side. Once you get really adept at this, you can do steps 2 and 3 together. Since the variables are going to end up on the left, I'm going to take away 4 from both sides so that the numbers will be on the right. Now the inequality has the 4's canceling and 2y and negative 2y canceling, so I end up with negative 3y is greater than or equal to 40 minus 4, which is 36. Finally, we're going to divide both sides by the coefficient of the variable, which in this case is negative 3. Negative 3 divided by negative 3 is 1. So on this side we just have y. 36 divided by negative 3 is negative 12. We divide it by a negative, so the inequality is going to turn around and face the opposite direction. It flips, and we end up with y less than or equal to negative 12. Finally, we're going to write the solution as an inequality and as an interval. Our inequality is all set. Y is less than or equal to negative 12. That means we want numbers below negative 12 on the number line. They're going to go to minus infinity on the left, but negative 12 is included because it's a less than or equal to, so we close it with a square bracket.